There's one equivalence we haven't looked at yet, which is the physical equivalence of access methods. That different access methods can be used at the leaves of these trees and get the same answer. So let's look at the idea of using indexes instead of heap files. And we'll assume that we have two indexes, one on reserves.bid, which is clustered, and one on sailors.sid, which is unclustered. Now, for reserves.bid, because it's clustered, we'll be able to get all the tuples out in 10 IOs, because those tuples will be packed onto pages. This is assuming that these indexes fit in memory, which is an assumption we'll make in our little example here. Now, on the right-hand side, sailors is unclustered, but note that the join column we're interested in, SID, is a primary key for sailors. So any lookup on SID and sailors is going to touch exactly one page in the heap file, and it doesn't matter whether that heap file is clustered or not. So unclustered will be just fine for this SID column. As I said, we'll assume the indexes fit in memory. It's going to simplify our analysis in the next slide. So let's look at this plan and figure out its cost. We said in this first bullet that it would cost us 10 IOs to get the tuples out of the reserves clustered index. So that's 10 IOs right there. And then for each reserves tuple, we're going to do 1 IO in the sailors table. How many reserves tuples are there? Well, there were 100,000 reserves tuples, and we took 1/100th of them. So there's 1,000 that we're going to push through this join. All right, and so we're going to do 10 IOs in reserves, and we're going to do 1,000 lookups in sailors for a total of 10 IOs. All right, and this is actually the cheapest plan we've seen throughout this whole lecture.